Dorian.
What are we doing?
Oh, well, today we're going to find the different masses and volumes of water.
What's our end goal to try to find?
I feel like it's density because it says density at the very end of my data table right here. Yeah. I think we're going to learn by using data to calculate a property of water.
Wow!
And do I need my goggles for this, Miss Mardorian?
You know what? Looking at the materials we have, we're using a plastic graduated cylinder and water, no chemicals, and we're not using glassware or heating. So I'm going to say no, we don't need to.
Hey!
Yeah!
All right. So step one, I'm going to tear the balance.
Oh yeah, tear the balance.
Tear the balance, make it go to 0.
Okay.
And then I'm going to find the mass of my empty graduated cylinder. Ooh, that's vague.
Ooh. There we go.
40.00.
It fluctuates sometimes, but whatever it ends up landing on, now it's 40.01.
Is it?
But 40.00 should be okay. There's some air moving.
Okay.
And that's, okay, massive empty graduated cylinder. I see what you did there.
I did. Okay, so now I'm going to put a small amount of water, okay? And does it matter? I just want each trial to be different.
Right.
So,
I would probably start small.
Space them out. I'm going to start with 20.
Cool.
Or try to start with
Ish, right?
20-ish.
Because we'll read exact.
Okay, it's actually 19. That's okay.
All right, so where are you going to read the graduated
Well,
cylinder?
I'm reading it at the meniscus at eye level right
come
here.
by you right now.
Can you see? And to me, it looks that it is 19.0. Doesn't it?
Let's see.
Agreed?
Yeah, I agree.
All right.
Okay.
So that's going to be my, well, that's my volume. Do I write
That's
that?
your
Oh, I write that
volume.
in my data table?
Mass of graduated cylinder. Oh no, yeah, volume.
Right here, 19.0 milliliters.
Cool.
Okay, so then my balance is on 0, it's tiered. Okay, I'm going to put the graduated cylinder plus the liquid on there.
Okay.
And I got 58.87.
Yes.
Okay, so that goes right here, 58.87
Mass of graduated
grams.
cylinder and liquid. Okay.
Okay, so how I find the mass of the liquid is I subtract the mass of my empty graduated cylinder from the mass of my graduated cylinder with water.
All right, so my water is?
So it's 58.87 minus 40, so that would be 18.87. If you couldn't do that in your head, you know, use a calculator. All right.
Very nice.
All right, in the last column, we can do that at the very end.
All right.
All right, so now I can just continue to add a little bit more water since I'm starting small and going larger.
Yep.
So, I suppose
That's okay. It's just, we know it's water.
it's water.
It's labeled. It's from the sink.
You even may have gotten it yourself. Oh, look at this. I think I got it exactly on 40. So I'm going to dry off my
that's not the...
cylinder.
I think I need lines behind it. Let's put some paper.
Can you see? It looked to me like it was 40.0.
I think so.
Okay. I tried
Maybe
to make
you double
it.
check because it's kind of hard to see through the camera.
It is a little. All right, so
you
I'm
check
gonna
out
use the paper here.
Yeah,
to
you
read.
check out the meniscus. So she's focused right now.
I'm very focused. Oh, is it on 40? Yes, it is. Okay, it's on. I'm gonna say it's 40.1.
Okay.
All right.
40.1.
It's a little bit above the line. So, volume 40.1 milliliters.
All right.
All right.
Now we mass, but wait.
But first, I have to tear the balance.
I have to tear the balance. There was a 0.01 there.
Oh dear.
Oh gosh.
All right.
Okay.
79.71. Right?
Yep.
Okay.
79.
79.71 grams. Sorry, that's upside down.
That's
here.
okay.
Okay. So now I do 79.71 minus 40.00, and I get 39. I'm like, brain break. 39.71 grams.
Grams because it's
Mass.
Look at her volume units. They're different. She put milliliters for volume and grams for mass.
Okay.
All right. Add more water.
More water. I'm trying to get it exactly every 20. It's hard. Oh, it's 59 59.5.
I'm gonna trust you.
Are you?
Yeah, I'm gonna trust you.
It is. You should.
I think we should trust her.
You can trust me. I mean, look at this face. Okay.
All right,
So,
what did you say?
59.5
59.5
milliliters.
milliliters.
Okay.
And mass.
Now mass.
Tear.
I'll just tear it just
in case.
Just in case. You never
Always
know.
want to tear. Even if you see 0, just push the tear. Ooh.
98.96.
96. Let's go
right.
96 because it seems to stay on the
98.96 grams. Okay, so 98.96 grams minus 40 is 58.96.
We got lucky with a 40.00 graduated cylinder mass.
So we can do this in our heads.
Yes.
Which is helpful. All right. All right, and then
Alright,
one
final
more
water
trial.
amount.
Woo! All right.
Go big.
Go big. Go big or go home. I'm going up to 90.
Oh, shoot. Okay. Do it.
All right, I think.
All right, Miss Thorburn, what's it say on the meniscus? She needs paper, which is okay. Using her resources.
It is. It's 90.0.
Is it? Yeah!
All right, so that's my volume.
90.0.
Milliliters.
Okay.
Okay, here's the big test.
Here it is. Oh,
Tear.
gotta tear that 0.00 off.
All right. And it is
Ooh.
128.63.
128.63.
Okay, which is here.
Yeah.
128.63. Minus
Right.
40?
88.63.
Yeah.
I love that mental math. Oh, Miss
All right.
Thorburn, you forgot something on your number 4.
Oh my gosh,
my
I forgot to
gosh.
put the units.
Grams. It's
Grams.
math.
Okay.
Okay, great.
So here's my data. So now I'm going to calculate the density. And looking at my numbers,
We need the
like
density.
we definitely need a calculator.
Yeah.
So the formula for density, I'm just going to write it right here. Density equals mass divided by volume.
And when we analyze this data, we're going to actually graph it. You will graph it on page 8. When we analyze it, we're going to see why that is the density equation.
Right. You're going to put the mass here.
Mass, yeah, on the y-axis.
Oh, yes, the mass on the y-axis and the volume.
Yeah, on that. It's written right here.
Okay.
So
And
they
the
know.
volume right here.
Yeah.
So you're calculating mass divided by volume. If you think about this, it's kind of like a math equation that you may have heard of before called slope.
Rise
So
over run.
change in y over change in x. So I'll do one example for you. I'm going to get my calculator.
Get the calculator. Now, while Miss Thorburn's doing the calculations, I'm going to be a nice lab partner. And I'm going to take this graduated cylinder and I'm going to pour it out back into the speaker. And then when I turn off the camera, I'm going to dry this out completely so that the next class has a dry graduated cylinder. Because it needs to be dry to get the initial volume of or mass of my graduated cylinder.
Okay, so the
Alright.
numbers that I'm using, we're not using this number, we're using the mass of the liquid divided by the volume of the liquid. So I did 18.87 divided by 19, and I got 0.993 blah, 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 but I'm just gonna write 0.99 grams.
Hundreds place.
Yes.
And we did grams divided by or mass divided by volume, which is grams divided by milliliters.
So this is the units
I like
of
it.
density.
Lovely.
Okay, next. 39.71 divided by 40.1. 0.99.
Oh,
Ooh, interesting.
0.9902.
Yeah.
So round to the hundreds, 0.99 grams. All right, you can keep that.
Okay.
In.
All right.
Try to beat her. Calculate the next one.
Yeah, because I have to think about this and read it upside down. Okay. 58.96 divided by 59.5. Whoa.
What?
It's 0.99 again.
What?
I keep getting the same. I keep getting the same number.
How is this happening?
Ooh, I don't know. Maybe because we're using the same liquid. Maybe that has something to do with it.
Oh, yeah,
Ooh.
we did use water the whole
We
time.
did use water the entire time. All right, final test.
88.63
88.63.
divided by 90.
Oh, that was 8.63. 88.63 divided by 90. Oh, it's 0.984.
All right, 0.984.
So I'm going to write 0.98.
And now she's going to have to find the average density, where she'll add up all 4 of our densities and then divide by 4 because that's the number of data gatherings.
And why do we want to find the average?
Because when we're doing our labs and we're doing measurements, by finding our average, it allows us to be a little bit more accurate. Ooh.
All right, so here is my average. I mean, you may have guessed, because I have 3.99s and 1.98, that it's going to round to 0.99.
Right, so 0.987 rounds up to 0.99 grams per milliliter. So that's the average density of our water. And so then when you graph it on the next page, your data, which you will do, and then you can check in with us afterwards. When you graph this and you compare your results of finding the slope of the line you graph and your density, you're going to find some pretty cool stuff. Cool.
All right, so what you'll have to do is, depending on which volumes you chose of water, you'll have to make sure that you space out the intervals correctly. So I went almost to 100.
Yeah.
And there are
14 lines.
There's 14
I
lines.
think there's 14 lines.
So I can go every 2 is
You could go by tens.
go by 10s. Yeah.
That would be okay.
All right. So I'll go by 10s, but since I don't like my graphs looking like super crowded, I just write every 20. That makes sense.
As long as you know.
As long as I know. Should I just plot 1 point as an example? Okay. Volume, and then the mass, I'm going up by the same intervals.
Same intervals because it was around the same numbers.
Yep. So every box is representing
10.
10 grams or 10 milliliters. Okay. Okay, so my first trial, the volume was 19. Okay, so here's my volume. It's going to be right in front of the 20. And my mass was 18.87. So when I plot the point, 19 is like right here, and 18.87 is like also a little bit below 20.
Perfect.
So it's like right there.
Yes.
Okay.
You'll continue plotting your points.
And then we'll draw a line of best fit to determine our slope.
Yep.
Yep.
Cool.
Thanks for watching.